Hello everyone, my name is Atharva Parande. I'm from SOC 1, roll number 28. In today's video, I'll be explaining my CW Lab project, which is Activity 6 IoT based environmental data logging and visualization on local host using NodeMCU. So, in this project, we'll need a ESP12E, a DHT11 sensor. We'll need a local Wi-Fi network. In this project, we'll build a built-in web server, which will we host on our local network via help of our ESP12E. Then we'll log in all the data we have collected from our DHT11 sensor, which will give us readings on temperature and humidity of the environment. We'll log in it in a CSV file, and lastly, we'll learn a Python data analysis for matplotlibs. This experiment aims to measure temperature, humidity, and then display them on a dashboard, logging them with timestamps. So we could finally do analysis of the environment condition using Python. So on the first part, we'll see the connections. So as you can see on DHT11, we need to connect our VCC to the 3.3 volt on our node MCU. We need to connect to ground on our node MCU. You could use any open ground here. Finally, we will feed the data we will be connecting from our DHT11 sensor to the D4 slot on our node MCU. Uh, this is this is just the overview of the things that we are going to do. And lastly, we'll have code that will run. So I'll be opening my Arduino IDE to install the code on our node MCU and run it. I have already written and uploaded the code in my Arduino IDE cloud. So if anyone is interested who wants to do this experiment, they could just search up my cloud name and they'll get the code for this experiment. Currently, I'll go to my cloud and get the code. Here's the code. It's 166 lines of code. I will be explaining almost every part of the code after I paste it here. So as you can see, our code is in our IDE. I will close this window. Now, before explaining the code, I would like to share a few important tips. First, whichever system you're doing this project in, it should be connected to a 2G network. It cannot be connected to a 5G because our node MCU cannot support 5G bandwidth. Next, we will connect our board to our Arduino IDE. We are using USB to connect our board to our machine, so we'll select that here. And in boards, I'll simply search ESP12E. So also another thing to note here, if you try to do this immediately after installing your Arduino IDE, this option will not show because your Arduino IDE does not come pre-installed with all the drivers required for your ESP12E. So you need to manually download those drivers on your PC. It's not that difficult of the task. You could watch a YouTube tutorial on how to download drivers for ESP12E on your Arduino IDE. After that, you'll be able to see this message and you'll be able to upload your code onto and do projects on it. For now, I'll simply select this and our USB port and click OK. Now, on the bottom, you can see our node MCU is connected to our IDE and we'll simply hit upload to upload the code. I'll fast forward the video because this takes some time. Meanwhile, The code is uploading. I'll explain the code that I've written and what every part does. So first, these are libraries that will require. First one is Wi-Fi library. Second is ESP8266 web server. Then we have a library to read our DHT sensor reading. Then we have one library to include time in our readings. Next is network setting. These are my Wi-Fi SSID and password. So our node MCU could connect to Wi-Fi and host to web server. Next is DHT settings on how it will collect data from the environment. This reads temperature and humidity, and both are digital values. Next we have data storage and web server. Now this is a bit of important part. This whole code is for NTP, which is time synchronization. Because our ESP12E doesn't come with no real-time clock, so we'll use NTP. This provides accurate data, date, and time, which is added to every sensor reading. Next is the web dashboard. So as you can see, this whole code is written in SQL. This is nothing but just the design of our website. Next is a JSON data. This code does nothing but converts the data that we have connected from DHT sensor, converts it into a CSV format. This is the code for CSV download button, and this whole code will help us actually see what's going on our ESP12E. Without this code, our our microcontroller will be like a black box. We wouldn't know what's going on. So as you can see, our code has successfully uploaded. I'll simply click on serial monitors or see what's going on. So it has been a time and it has not connected to a Wi-Fi. In such cases, you could try to upload it again. Most of the time it works. So I'll just fast forward the video here because we have already seen this process. As you can see, our NodeMCU has given us IP address on which it has hosted a web server. Now we can simply copy this and paste it on any browser or Internet Explorer that you would like to use. For in this case, I'll use Chrome. One thing to note that this IP address will not work on every device. The device has to be connected on the network that the board is operating on. So that's basically what localhost is. So we'll just search up the IP address. Here is our live reading. As you can notice, these are getting updated every 2 seconds as our code says. And currently the temperature in our room is 25 degrees Celsius and the humidity is at 60%. So this sensor is not very sensitive. So if you want to do any kind of data analysis, I will have to make variations artificially. So I'll just blow hot air on the sensor to make variations. As you can see, the temperature went up, so does the dramatic increase of humidity. We'll download this CSV file by clicking on this button. Then we'll close both the windows. Now we have our CSV file, and this part is not included in the PDF, but we'll still do a bit of data analysis with the data that we have collected because this is the ultimate aim of the experiment. We'll open our Visual Studio Code. Here you need to install matplotlib and be in a virtual environment where you could run these experiments. And you need to also import Panda. So I'll and yeah, the second thing that you need to worry about is your directory that your CSV file has saved in. This should be accurate. If this is wrong, uh, a, our program will not be able to take the data and do analysis on it. Now I'll just hit run. Here you can see the temperature variation over time. So at the beginning, it was very stable until I started blowing hot air on it, and after some time, it started decreasing as I stopped blowing air on it. We'll have next graph if is of humidity. So as you can see, it jumped up really high, really quick, and then settled down a bit. Next is temperature as humidity over time. As you can see, we could plot data on time. And the lastly would be a scatter plot of both temperature and humidity. So this gives you an idea how we could use this setup to actually do some data analysis and data visualization. So thank you for watching my video.